And normally we mentioned in the index table we have the entries. These entries composed of both the search keys as well as pointers, right? Pointing to the concrete data examples or data tuples in the table we store in database systems. And you may wonder what is a search key. According to our previous definition, we can use any subset of the attributes to compose the search keys, right? So we can use any attributes for the search keys actually. And you may also wonder how to correlate the search keys with queries and with index tables. In this page, we show you with some examples about search keys we can have for some concrete tables. So normally in a query, we can have different some queries, right? Like if we do the select from where, in the where condition, we want to match some attributes, right, with some given values. And for this condition we can easily have some equality queries, right? We will find some data tuples matching some given values, and every feed value is equal to a constant value which is provided in the query, right? Like we can have a query matching a person whose age is 20 and salary is 75k. It's called a equality query, right? Because we are matching the attributes with some given values. Another query we can have is called range query, right? So given some attributes, we want to find some tuples with the values in a certain range for some attributes, right? Now some field value is not a constant but a range. For example, we can have some example like we want to find some people whose age is 20 and salary is larger than 10k, for example. So this is about the attributes we can use for the queries and search keys. And you may also wonder how to correlate these search keys and queries with index tables. On the right hand side we have an example. In the center part we have a table. This table is for storing the data tuples. This is a concrete table for storing the data. Inside this table we have some many records about some person. This table has 3 attributes: name, age, salary of the person. And we have 4 tuples: Bob, Cal, Joe, and Sue, right? We will provide the name, age, and salary of this person. And given one table, for storing the data, how many index tables we can create? The answer is we can have so many different index tables depending on the search keys. Right now we have 3 attributes. By combining any of the attributes together, we can compose an index table. For example, by combining this age with salary, we can create a table, create an index table for it, as shown on the left hand side. We have age, salary. Remember, in the index tables, we need to sort these entries. If we have 2 attributes as a search key, right? We have both age and salary. Then how can we sort them? Sorting one attribute is very easy, right? However, sorting 2 attributes is very hard. Now here in this table, we sort according to the first attribute first, and for the entries with same age attribute, and we can first sort them according to the salary. In this way, we can sort all the entries inside this index table. Like we have 11, 80 as the first entry. We have 12, 10 as the second one, because 12 is larger than 11, right? And we have 12, 20 as third one. The 12 is the same, however 20 is larger than 10, therefore it is behind this second record, right? And the last one we have is 13, 75. The 13 is larger than 12, right? In this way, we can sort all the entries in the index table. So you can see, in this one we sort according to age first, and then first sort according to salary. And we could sort it according in another way, right? Depending on the order we place these entries. If we put this salary as the first attribute, age as the second one, then we can sort these entries in the index table in another way by creating a new index table, right? This is another index table we can create for our data tuples. In this one, we also have the age and the salary. However, we have the salary as the first attribute, age as the second one. Therefore, in this one, we sort according to the salary first, and then further sort according to the age. You can see these 2 index tables, even though they cover the same search keys, however, the order is very different, and the entries stored in them are also in different orders. In other words, given two attributes as search keys, we actually can compose a different index tables for it. Besides search keys, we also have one entry as a pointer pointing to the concrete data tuples, storing these records with certain attributes as search keys. Now this one, the first one is 11, age, 80 as scenery. It points to KL, right? Similar for the remaining entries. So you can see this index table is sorted according to age scenery. However, our data tuple is sorted according to name actually. In other words, there is a mismatch, right, between this data tuple records in the tables versus this index table. In other words, this index will be unclustered because the order is mixed together, right? It's not sorted according to the age scenery as shown in the index table for tuples. They are in different orders. Okay, so this is to create an index table with two attributes. We can also create an index table with one single attribute, now with only age or only scenery. This will be relatively easy, right? Because we only have one attribute and such key, we can just sort this index table according to its value. We also have a pointer pointing to the data tuples with records matching the search keys, right? Similar for the scenario. Okay, so given one data table with some tuples, we can actually create different index tables for it, depending on the search keys we use. Even for the same search keys, we can also have different index tables depending on the orders we compose these search keys. So normally when we create the index tables, the index tables are always sorted, right? Are always sorted. And this sorted order can be different from the concrete table we use for sorting the tuples in the records. And to maintain such sorted index table is very hard actually. It is very similar to a list, right? If we maintain a sorted list, it's very hard because this index table keeps changing and we do more queries. If we have a query, we need to change both data tuples as well as these index tables. Now here, if we want to search for someone whose age is 20 and salary is 35K, we first check the index table, right? Age, salary, to see if we can find some matching records or not. So far, we cannot find a matching record, right, with 20, 70K. And then the system will do an insertion about this search keys, providing the query into this index table, and also add one point pointing to some concrete tuples with this matching records. In other words, as we are doing some queries, we have to update these index tables accordingly if we have some new search keys which never appears in this index table. So you can see, you can follow me, right? This index table is created and also growing as the system is running. Okay, so this is about the search keys. In the real world, I have so many different search keys we can use, right, for composing the index tables. And in this page, we show you the example with the textbook. Given one textbook, how many indexes we can have? We can have so many different indexes, right? At the front pages, we have a table of contents. At the end of the pages, we also have this topic words, right? Providing some keywords referring to some pages, mentioning or defining these keywords. We also have this in all the index information as well. And what are the keys for these indexes as well as records? So for the table of content, normally we have this chapter number as well as titles as the keys. And the records we have will be some pointer pointing to certain pages, right, or in the textbook. And for the topic words, the keys we have will be the topic words, right, some phrases. It will refer to some concrete pages, mention or define these keywords. Then the question will be, are these index tables clustered, dense, or primary or not? For table of content, it is clustered, right? Because normally the index table will follow the order, right? It is sorted according to some pages of the chapters. The textbook is also sorted according to the chapters, right? In order. So the table of content is sorted, therefore it is clustered. However, for the topic words, this index is not, right? because the topic words can be mixed together for the pages. And some words can be mentioned in the front pages and some will be mentioned in the later pages. How about density? The table of contents normally it is yes, right? We want to provide all the chapters in the textbook in the table of contents. However, for the topic words, it's not right because so many pages will never mention two in the topic words within text table. And to whether these keys are primary or not, it really depends, right? Okay, so this is about the example we can use for illustrating this index tables with textbook.